got them in the entrance of our production.
Did you try to use different shapes? That will have an effect.
Yes, this shape was the best one, better than spherical. It is important in absorption, yes.
Okay, thank you very much.
Thanks. So I think we should discuss more about different subjects.
Yeah, no problem. Thank you.
Any other question? Yeah.
Thank you. Thank you, Professor. I have two questions, actually. The first one is like you're using a small concentration of nanoparticles, but still for enhanced oil recovery, you need to use big amount. So how do you do this? How you go from lab to let's say, to have this thing? My second question is like
so let me discuss first. You are right. It is a step-by-step approach. Now we are in only laboratory scale. And it is, then we should go the larger, and at the last, I think it takes a few years, of course. But our beauty in research is, I think, mainly focusing this part. And then the other parts, I think, is an engineering procedure, and I think it is same for different flooding procedures. It is same for different. So I think if we got good results in this stage, it is possible that we check them the next steps.
My second question about like the stability. You showed the stability at high temperature, but the pressure is there. So I don't know how you look at it, because you use like TGA, which is like you can't check for the pressure. So
No, we check different available methods to check the stability. For example, we check the TGA-DSC to understand in which range of temperature it is stable. But it is only for temperature, okay? For stability of inside the pressure, we use another vessel, very simple. We add pressure, and it was, there was no problem for a short time, which is necessary for flooding. You know, in nanoscience, we want to try different approach to understand. It is a little different from engineering approach. We want to understand what is the problem that our nanoparticles is not stable in high temperature. If we understand, we can modify, and then we can check it in both high temperature and high pressure conditions. For this approach, we do not use any surfactants. We have to, because we have problems when we add surfactants onto our nanoparticles, and it was not stable in high temperature. It was stable in room condition, our nanofluid, but when we increase the pressure and the temperature, it was not stable. So it is another approach to check it.
okay, thank you.
I have a quick question.
Okay, quick question, please.
Yeah, thank you very much for a very nice presentation. Just one quick question regarding the solid material. It seems to me there must be some electrostatic interaction between the nanoparticle and the solid. What do you expect if we have different reservoir formation, different rocks material? How will that interaction change between the nanoparticle and the solid? When we change the reservoir and the rocks, everything will change.
There are models that, you know, the core sample contains different materials, but you think that we have only one material. We can measure zeta potential for the using flooding material, for example, water with selected salt concentration. We can measure the zeta potential of the surface Also, we can measure the zeta potential of our nanoparticles. Then we can say that it will absorb or not. The main mechanism, same as you said, is electrostatic absorption. There are other mechanisms, but I think this is the main one. So we can check for one reservoir which one is better, which nanoparticle we should select for first steps. I should emphasize that in this approach, we want to select everything as soon as possible and then check in the same way as other users.
Okay, gentlemen, for the constraint of time, we can continue our discussions at coffee break. So again, let's thank Professor Hadian for his talk.
Thanks a lot.
Our next speaker is Dr. Tariq Muhyiddin from Sultan Qابوس University, College of Science, Physics Department, and he will present to us nanotechnology research at SQ. Dr. Tariq, floor is yours, but you have less than 20 minutes.
Bismillah ar-Rahman ar-Rahim. Again, I'm really honored to be speaking from this podium this morning. I was one of these people who visited Iran back in February, the university administration, and I was really intrigued and overwhelmed with the opportunities that exist for scientists in Oman and SQU especially, and the people scientists in Iran. So what I'm doing today is showcasing the possible collaboration areas that we could discuss possibly throughout this 2-day workshop. It will be very difficult for me to cover the whole university because there are different areas and different people working in different areas of nanoscience. So to do justice to everybody, what I've planned to do is just showcase to you the facilities we have in around SQU, and through that I'm sure you will have a lot of ideas and a lot of potential research work that you can do. So please, after I've done, if you want to see anybody or meet anybody using particular technique or an instrument, please let me know. I can hook you up with them. The nanotechnology research at SQU is mainly concentrated. I'm saying mainly concentrated, but there are other places where people are working in this field. In the College of Science, which is just across the hall here, and what is the Research Council Chair in Nanotechnology for Water Desalination. So these two main entities are where the nanotechnology research goes on in SQU. In terms of facilities, I will start with characterization facilities which are available to us. One of our prized possessions is the field emission electron scanning electron microscope and the high field emission, high resolution tunneling electron microscope. Hoist. This machine here, probably you will go on your tour today to the Central Analytics Research Facilities Unit, and you will have opportunity to see this unit here. This one is housed in the College of Medicine. If you are interested, we can arrange for you to go and have a look at that. In addition to that, we have AFM, an STM facility from VICO, and a lot of our scientists use this for surface characterization, for MFM, and a wide range of applications. In addition to that, I remember Professor Hadian mentioned the XPS. So we have an extremely good facility with the XPS. Again, I'm trying to knock on areas where we can collaborate. And of course, the normal X-ray and XRF. In terms of fabrication facilities, we have a chemical vapor deposition facility, which is the one you're seeing here is the one we had earlier, and we should be getting a new one very soon. A magnetron sputtering system for thin film deposition, for device fabrications, and what we have in the pipeline is, probably Dr. Salim can talk more about it, is the electron beam lithography machine, which should be coming in very soon, in a few months, and laser beam lithography system, which we are hoping to use for teaching as well as for research, and a mask aligner. The idea here is mainly we have enough characterization, but we want to have more of fabrication facilities. So that will be included there. And another desktop STM, again, which we also used for teaching. And a thermal evaporation system for devices as well. So that was the College of Science. For the chair in nanotechnology, which is mainly focusing on water desalination, the main themes in that facility, or the chair is looking after, is metal oxide nanostructures, capacitive desalination. So if you're interested in having a look at these facilities, we can arrange. It's not a part of the program, but we can arrange for you to have a look at it. Induced renewable desalting, and micro and nano membranes. In addition to that, again, I'm not covering everything. We can to do justice to everybody. And some of the other facilities that they have at the chair in nanotechnology is photoluminescence, Fourier transform, infrared spectroscopy, and I was told that very soon we will have a Raman spectrometer as well. In terms of research, I'm just going to touch a few things which I am personally involved in. Is graphene. That's my background in. So what we do is nanoscale simulations. We study the effects of strain on graphene membranes. And one of our publications recently, we observed almost a 40% drop in the mobility in graphene when you apply strain to it. So about 20% strain should give you 40% change in mobility. So this is work continuing in this. So this is mainly theoretical work. In terms of, I could say, biophysics or human physics, whatever you call it. One of the studies we do and hoping to continue is a nanoscale study of human hair. So all these are SEM images of human hair treated with traditional materials which are very common to our culture. I'm sure you're all familiar with henna. There are two other materials that we use in Oman. Yas and Sidr. So the idea was to measure the strength using atomic force microscopy of the hair when it is treated with different chemicals, and as well as these traditional cosmetic materials. In addition to this, we have the chemical vapor deposition facility, and we have been able to synthesize silicon nanowires. And the work we do here basically is to work out the phenomena or the catalyst which is taking place for the formation of silicon nanowires for different morphologies. The interesting part, which this is quite recent work, is these are zinc oxide nanowires, which we have been growing on silicon oxide. Zinc oxide, as Dr. Salim said, has a lot of applications. One of them is possibly absorbing gases, associated gases in the petroleum industry, H2S absorption. That can be done on a nanoscale as well, zinc oxide nanoparticles. We are suggesting that the nanowires would have a larger surface area, so in such will be absorbing more gas for a given volume. This is something, I would say, straight out of the laboratory, very recent. So what we've done here is grown zinc oxide nanowires on graphene. This is also very recent work. Only a few people have published it around the world. So you have a graphene wafer, which is commercially available nowadays, and we, using CVD, deposit these zinc oxide and study basically the formation of these nanoparticles. So these are, in our studies, something very recent or something very novel, especially when something is growing on graphene. With the combs, we also have nanowires, zinc oxide nanowires on graphene. So again, people are trying to put in graphene everywhere and trying to grow a lot of different things on it. So we started with zinc oxide, but we don't want to restrict ourselves to that. We would like to explore other materials as well. All right, a short presentation, but again, as I said, please, you've seen what we have, and I'm sure you will have some idea of some way we can collaborate, and thank you for your time. Okay.
Thank you, Dr. Tariq, for the informative presentation, and now floor is open for questions.
Okay.
Questions?
We can discuss later.
Maybe Adil, my PhD student, can ask question. All right.
All right.
Okay.
All right. Thank you.
Thank you. Our next speaker is Dr. Izzatullah Kazimzadeh from Ministry of Oil in Iran, and he will present to us the routine and special core analysis and PVT services.
Is this one?
Yes. Ay Doktor Ayetullah. Ay Doktor Ayetullah. فلاش من چیکار که؟
I think this one. The other one.
It is not main. Another. Okay. Thank you. Okay. In the name of God, It's my pleasure to introduce the capability of RIPE in IOR and EOR. The name of my presentation is Routine and Special Core Study and PVT Study, but I prefer to state some capability of RIPE about EOR and IOR, and then in this presentation, we will focus on core analysis, special core analysis, routine core analysis, and also PVT. In my presentation, first I introduce RIPE and only organization chart of RIPE and EOR and IOR roadmap for is necessary for during a stage of EOR and IOR. And one of the main stage of each EOR and IOR process is laboratory measurement. In laboratory measurement, in RIPE we have more than 50 years experience in core study, PVT study, EOR study, and also geoscience study. And for each EOR process, we need payment job, simulation activities, lab activities, and field activities. But in reservoir study, we have experience for preparing more than 15 fields, preparing MDP, Master Development Plan. Research Institute of Petroleum Industry is the largest national company in Iran, it was established in 1959. We have more than 2,000 employees at this time working with Research Institute of Petroleum Industry is subsidiary of Oil Ministry. Here is 4 main companies of NRC and Research Institute of Petroleum Industry, subsidiary of Ministry of Petroleum. Our mission in petroleum industry of RIPE is providing services, laboratory, technical services, consultancy, and also the main role of RIPE is providing technology. Technology provided in different areas of upstream, downstream, and energy and environment. We have different sites in different locations of Iran. The main site is in Tehran that you had visited from site. And in Kermanshah for upstream activity, Ahvaz for upstream, and Resh Iceland for. Thank you. Just stay here. But this is organization chart of RIPE, Research Institute of Petroleum Industry, upstream, downstream, energy and environmental, and directories including technology, international affairs, procurement, and commercial affairs. In each faculty, we have different divisions. You see here divisions related to downstream technology, polymer, petroleum refinery, chemical science and technology, nanotechnology and catalyst, and also in energy and environmental, environment, biotechnology, industrial production, energy efficiency and optimization, analytical chemistry research group. But in upstream we have 3 main divisions, petroleum engineering, reservoir study, and field development, geoscience. These divisions cover all of activity related to value chain of upstream, from production, appraisal, development, and production of oil and gas reservoir. For example, in petroleum engineering division, we have production group, enhanced oil recovery, drilling technology, drilling mud and cement, PVT study, core study. And also in reservoir study, field development and management, reservoir studies, reservoir simulation, petrophysical study, and geoscience, we have petroleum geology, geophysics, and geochemistry. At this time, we have 195 staff in RIPI with different degrees distribution, master, doctorate, bachelor, and during the recent years, we have some international clients, such as Sintef, Statoil from Norway, Cesar Rokertin University from Australia, and also Eni Ajib Edison from Italy, IFB Total, French, Japan, Gion from Japan, GNOC Nippon, Jomek, and also Shell Scholumberger from Netherlands, OMB from Austria, and Sinopec and CNRC and CNPC from China. This slide is from Scholumberger. This slide shows us for reducing uncertainty and risk and increasing knowledge and understanding and investment and recovery over the time of reservoir, we need to do different taxes. Each EOR roadmap starts from FDP, Field Development Plan, screening the EOR method, test in laboratory, model feed and process, design field test, perform pilot, monitor, and analysis. All of this data come back to this model and for reducing uncertainty and risk. And after designing the pilot, the data from the pilot come back to the field development plan, and during the time, this process repeated. And after implementation in the field, the data from the field come back to the model, and all of these cycles will be repeated. Fortunately, in Research Institute of Petroleum Industry, we have good experience for tests in laboratory that this data is very, very important for reservoir modeling and simulation, any scenario related to enhanced oil recovery phenomena. But in laboratory, we have all laboratory related to upstream, core study, PVT study, UR study, and geoscience study. In core study, two main jobs that the name of my presentation is routine and special core study. We will focus in these topics more. Routine rock properties, advanced rock properties. We do all of routine jobs related to rock properties in Research Institute of Petroleum Industry, natural gamma radiation and depth matching, consolidated and unconsolidated core plugging sample, preparing of sample, trimming, fluid saturation measurement, helium porosity, petrophysical properties measurement, and we will discuss more about this item, and also advance of rock properties, including relative permeability, capillary pressure with different methods, electrical properties measurement, wettability measurement, interfacial tension measurement. And also rock physics measurement. As you know, VP velocity measurement is very, very important for AVO, for example, amplitude versus offset study. This system is, the first step in core analysis is measuring gamma ray. Gamma ray is used for depth matching between wire-like data and core data, and also by measuring thorium, potassium, uranium of the rock sample, we are able to identify the type of shale we have a standard graph in this area. And also core photography and core slabbing, core plugging machine. Unconsolidated plugging is a special technique is needed for getting plug sample for loose sand. You can suppose that in the reservoir we have some formation that the cementation is very, very low, and such as sand in the beach. We have to prepare the plug sample from this formation without any change in texture. We have to freeze the sample until minus 60 degrees centigrade, and after then we get plug sample with a special technique, and by shrinkage Teflon tube scanning, we get such as consolidated plug sample. And also cleaning and fluid saturation measurement. For fluid saturation measurement, we have two methods, Dienestag and retort method. I think that you are familiar with this method. And for drying sample under humidity, we have to clean the sample. We have to dry the sample under humidity. Porosity measurement is standard equipment for measuring of porosity. Fortunately, in Iran, we made this equipment, porosity, permeability, water flooding. All of this equipment at this time are made in Iran. Permeability measurement both for plug sample and whole core sample, and another parameter is pore size distribution is necessary for geological study, and also for example for design of gravel pack in the production. And one of the tasks in core study after determination of petrophysical parameter is selection sample for a special core study. One way to selection sample for a special core study is hydraulic unit delineation. As you know, it isn't direct relationship between porosity and permeability, but in carbonate reservoir rock, because pore geometry is not allow us to correlate a simple correlation between porosity and permeability. Different methods exist for this correlation, but hydraulic unit delineation is that introduced by Einfeld et al. It allows us to classify the rock sample with different hydraulic units. Each hydraulic unit has a flow zone indicator, FZI. For a special core study, we select sample from each hydraulic flow units. And also, this system is dedicated for measuring porosity and permeability, Klinkenberg permeability, pore volume compressivity, grain density under confining pressure from 800 to 10,000 psi. Another system for compressive measurement is RCS, reservoir compressivity system with 3 pumps. One pump for pore pressure applying the core sample. Another pump, one pump is used for confining pore pressure, and another pump is radial and axial pore pressure. Axial confining pressure is used for measuring reservoir rock compressivity under reservoir conditions. For example, 2 scenarios exist for measuring rock compressibility. One of them is constant pore pressure, another is constant confining pressure, overburden pressure. With this system, we are able to measure two types of compressibility pressure, compressibility factor. Another factor is very, very important for saturation determination. In Archie formula is cementation exponent, constant A, and saturation exponent. With this system, we are able to measure cementation exponent and tortuosity factor. As you know, this graph shows that this graph is from Fork and Moon, that illustrated that SAW at constant value as M is, for example, conventional value of M is 2. But in carbonate reservoir, maybe M varying from more than 2. For example, if a real value of M is 4, this water saturation may be 100. With conventional value of M is equal to, you consider that 3% water saturation. That in real case may be completely disappear, this amount of oil that you consider as 70%. The major factor of uncertainty in calculation of water saturation with log data is cementation exponent, and another is saturation exponent. This system is used for measuring cementation exponent under reservoir pressure. But temperature is not important in measuring formation resistive factor. But another parameter that in the especially our core studies, capillary pressure. 3 methods exist for measuring capillary pressure. One of them is mercury injection. This is a micrometric system that with this system is used for measuring capillary pressure and pore size distribution. Because mercury is strongly non-wet, this data that we obtain from this system is good accuracy for pore size distribution. This is maximum pressure of this system is 60,000. This 60,000 psi is not applicable for capillary pressure, but is only for pore size distribution is very important. But and also we have another equipment, the old mercury injection handy pump until 2,000 psi is used for measuring capillary pressure and also pore size and pore throat size distribution. Another system in a special core study is IFT, interfacial tension measurement, for measuring this parameter up to 10,000 psi.